Today we'll be looking at test of continuity of a function at point A, B. Prove or disprove that the limits of the following functions at their various points are continuous. Now, how do we prove that these four questions, are relatively continuous? We'll test them with what? These four steps I mentioned in my last class. And let's say I'm going to apply them all. Step 1 says you should tend x to a of what the limit as y tends to b of f of x comma y. That is, you put x outside, put y inside of the function given to us in this question. Number one question is what? Limit as x tends to 0, y tends to 0 of what? X raised to power 4 minus y raised to power 4 all over x minus y, where x equals to y, they both are not equal to 0. If they are equal to 0, what happens? This becomes what? 0. And this 0 makes my function undefined. So, now let's see. I've started solving already. Limit as x tends to 0 of what? Limit as y tends to 0 of my function as I was told to express it here. From there, this now becomes what? It means wherever I see y, I put what? 0. That's what I did here. Limit as x tends to 0 of what? X raised to power 4 minus 0 raised to power 4 over x minus what? 0. From there, on subtracting, what happens? Limit as x tends to 0 of x raised to power 4 over x. Now from here, I want to put my x as 0 wherever I see x. Before I put it, I can factorize. Factorizing, I bring x out from the numerator. It remains what? X raised to power 3. For the denominator also, I bring x out from here. It remains what? 1. On cancelling, what remains? I'm going to have it as what? X raised to power 3 over what? 1. From there, it now equals to what? Limit as x tends to 0 of what? X raised to power 3 only. Now I can now sufficiently put my x as 0. Putting my x as 0 in this function becomes what? 0 raised to power 3, which equals what? 0. And I said this is equals to f1. Why? Because I have 4 steps to test for, and then for the 4 steps, I'll be having f's for each of those steps. Now, after getting the f's of each of those steps, I'm going to compare. They must be equal. If they are not equal, it means it is not continuous. If f1 equals f2 not equals to f3, it is not continuous. If f1 equals to f2 equals to f3 not equals to f4, it is not continuous. If f1 is not equals to f2, it is not continuous until the 4 satisfy the same or provide the same solution. That is when it's said to be what? Continuous. So number 2, step 2 is by what? Tending y first to the point, then tending x to the point. How do we go about that? That becomes what? Limit as y tends to what? 0 into limit as x tends to 0 of what? X raised to power 4 minus y raised to power 4 all over x minus y, which now becomes what? Limit as y tends to 0 of, wherever I see x I put 0, that becomes 0 minus y raised to power 4 over what? 0 minus y. Now from here, this now becomes what? Limit as y tends to 0 of, this is what? Minus y raised to power 4 over what? Minus y. From here, I have it as what? Limit as y tends to 0 of, if I bring minus y out, what remains? Y raised to power 3. If I bring minus y out for the denominator, it means what? 1. Which now also becomes limit as y tends to 0 of what? Y cube. This will cancel this out. Now from here, putting my y as 0 now becomes what? 0 raised to power 3, which is equals to 0, which is equals to f2. Now since f1 equals to f2, I can continue. Now for number 3 step says what? Tend x to a and tend y to what? Mx. Whatever I see y, I'm going to put mx in that case then. So tending limit as x tends to 0 of what? Limit as y tends to what? Mx of what? X raised to power 4 minus y raised to power 4 over x minus what? Y. This now becomes limit as x tends to 0 of what? X raised to power 4 minus, now putting mx for y, mx all raised to power what? 4 all over x minus what? Mx. So why I see why I put mx, why I see why I put what mx. From here, let's expand relatively. So I'm going to have it as what? Limit as x tends to 0 of what? X raised power 4 minus m raised power 4 x raised power 4 all over x minus what? Mx. From here, I have this as what? X raised power 4 minus, expanding this becomes m raised power 4 x raised power 4. This is the same. So let's continue. This now becomes limit as x tends to 0 of what? Collecting like terms. X raised power 4 is common in the numerator. Okay, into what? 1 minus what? M raised power 4. That's what remains. Over, for my denominator, x is common. What remains? 1 minus what? M. Now from here, what do I have? This goes in this once. It remains x cubed. So I'm going to have it as what? Limit as x tends to 0 of x raised power 3 into 1 minus m raised power 4 over what? 1 minus what? M. Now from here, I can now what? Turn my x to 0. Wherever I see x, I put what? 0. Putting 0 here becomes what? 0 into 1 minus m raised power 4 all over 1 minus what? M. Now if I multiply this and divide by this, I'm going to get my answer as what? 0. And 0 equals to what? F3. So since F1 equals F2 equals F3, I can continue to the last stage. Count it now. So whatever I do here, whatever magic I do here, I cancel this one out also. I'm multiplying by 0. I'm dividing by 0 as the numerator. So it is still 0. Step 4 now. Step 4 says is what? You should tend my x to a and then turn my y to what? Mx squared of the same function. So that becomes limit as x tends to what? 0 into what? Limit as y tends to what? Mx squared of what? X raised power 4 minus y raised power 4 all over x minus y. And let's see this. This becomes what? Limit as x tends to 0 of what? X raised power 4 minus mx squared all raised power what? 4 all over x minus mx squared. Now from here, what do I have? This becomes what? Limit as x tends to 0 of, applying indices here, this becomes x raised power 4, this becomes what? M raised power 4, x raised power 2 times 4 is what? 8. That's indices over x minus what? Mx squared. From here, what do I now do? What I will do here is very simple. I would collect like terms. Limit as x tends to 0 of x raised power 4 is common. This remains what? 1 minus m raised power 4 x raised power what? 2. Because 8 divided by 4 is 2 relatively. So from here, what now remains? X is common. What remains? 1 minus what? Mx. If x comes out from here, this becomes x. If x comes out from here, this becomes what? Mx. Now from here, this now equals to what? This cancels one of these remaining 3. Limit as x tends to 0 of x cubed into 1 minus m raised power 4 x squared all over 1 minus what? Mx. Now putting my x as 0 becomes what? It becomes 0 into 1 minus m raised power 4 x squared all over 1 minus mx. The same thing goes here. Whenever I multiply and divide both sides by what? Divide, by what? 0. My answer becomes 0, which is equal to what? F1. Finally, since F1 equals to F2 equals to F3 equals to F4 equals to 0, I can now make a conclusion that what? Therefore, the function is said to be continuous at what? 0. Since I got 0 throughout, it means it is continuous. That is not, I don't mean that whenever you are solving any question under continuity, you get 0. For this solution, I got 0 from f1 down to f4. Since they are the same thing, it means that this function is what? Is continuous.